Hello and welcome to today's lecture. This is lecture number 48 of our course Blockchain and its applications. Also, it is the third and final lecture on the topic of blockchain interoperability. So, these are some of the concepts that we will cover in today's lecture. First of all, we will extend our previous discussion on cross-chain swap, where we talked about two parties in the last lecture, and once we have discussed how multi-party can also participate in such cross-chain swap operations, we will see that how interoperability can be also done in permission blockchains. So far we are talking about permissionless blockchains. And in the context of permission blockchain, we discussed it before in our first lecture on interoperability, where we mentioned that for permissioned blockchain, it is about data transfer across multiple such blockchains. Specifically, we will take a look at one such work, research work, very interesting work, where they talk about such data transfer across multiple hyperledger fabric networks in two different verticals. So, two different business verticals which we will see. So, first we look at the keywords for today's talk. Of course, cross-chain swap, permission blockchain interoperability as mentioned, and then we will see that there is this notion of interconnection relays which led such interoperability in permission blockchain in the particular work that we discussed. So, there are of course other pieces of work which are very interesting and we can always look at those. So, we are looking at one particular example which is representative of such permissioned blockchain interoperability. So, first we complete our discussion on this atomic cross-chain swap in permissionless blockchains that we started in our last lecture. So, we look at a multi-party scenario and we take this particular example from this paper. So, this is that paper that we mentioned that in this PODC 2018 conference, which is the paper is titled Atomic Cross-Chain Swaps. So, this particular example that we discuss here, these are taken from this paper that I mentioned. So, you will see that in this and next few slides we are taking the examples and the steps from the paper that has been mentioned. So, let us take this example of three parties now, and this can easily be extended to more number of parties. So, let us see that we have a situation where there is this need that there is this person Carol who wants to sell her Cadillac for Bitcoin. So, she would only accept Bitcoins for selling her car, a Cadillac car. So, again this example, as I mentioned, is taken from this paper. Now, so she has a buyer in Alice. So, Alice is willing to buy Carol's Cadillac, but the difficulty is that Alice is not going to pay with Bitcoins. So, she is willing to buy it, but she would pay only in another cryptocurrency, say call it this altcoin. Now, this is a problem, right, that Carol would like to sell her Cadillac, but as mentioned in the first point, she would like to get paid in Bitcoins. Alice is willing to buy, but she is not willing to pay in Bitcoins. So, luckily we have this situation where there is this third party Bob who is ready to trade altcoins for Bitcoin. So, now we have this Bob who is going to help this transfer, and she can exchange Bob, he can exchange these altcoins for Bitcoins. So, now we have this situation that Alice, Bob and Carol, they arrange a three-way swap. So, what we need to do is that Alice has to transfer her altcoins to Bob, because once Bob gets those altcoins, Bob is willing to pay the equivalent of Bitcoins, but to whom will Bob pay? He will pay to Carol. And once Carol gets those Bitcoins, because Carol is interested in getting paid in Bitcoins, so instead of getting paid directly from Alice, Carol gets paid from Bob. That is all it is doing. And Bob, why is he paying to Carol in Bitcoins? Because he is getting the equivalent number of altcoins from Alice. And so, when finally Carol gets the Bitcoins, the required number of Bitcoins from Bob, then Carol is willing to transfer title of her Cadillac, so the documents for her car to Alice. So, you see that we make a few basic and fundamental assumptions. One is that there are of course three different networks: the Bitcoin network, the altcoin network and this title network. So, title means this blockchain network which maintains the history of these titles, the registration related documents, the vehicle registration related documents for different cars and so on. So, that is the situation. So, it means that this most importantly the transfer of this title. So, this is all happening in a particular blockchain network, these are not happening outside the network. So, we make the assumption about the existence of these three networks. So, that is the most important part, and of course, that pairwise they should be belonging to the same network, because if Alice has to transfer her altcoins to Bob, so both Alice and Bob should be having accounts in the altcoin network, and similarly between Bob and Carol, both of them should be there in the Bitcoin network, and likewise between Alice and Carol, both of them should be having accounts, or they should be member of the this title management blockchain network. So, that is what of course is the basic requirement. So, now let us see that how one proceeds. So, it goes in the steps which were exactly similar, these are exactly similar to the ones we discussed for these two party swaps. So, instead of that we have these three party swaps. So, what happens, like that example, Alice would create a secret S and then computes its hash, which is say H. Now, Alice would publish a contract on the altcoin blockchain network, which will be an HTLC contract as we discussed, and hash time lock contract with hash lock H and a time lock of 6 delta in future. So, we are showing 6 delta in future to denote that Alice's contract will time out at the very end, and that contract is going to do what? It would transfer her number of altcoins to Bob. So, that has been say negotiated between Alice and Bob, that if the Cadillac say it costs say 100 bitcoins, and 100 bitcoins is, as an example, let us say it is 1000 altcoins. So, it means that Alice is going to pay 1000 altcoins to Bob, and Bob will pay 100 bitcoins to Carol, and Carol will transfer her car's title to Alice. So, once Alice has published this contract, so this is important, that once Alice has published the contract, and Bob first would confirm that Alice's contract has been published on this blockchain, then only he will publish a contract now on the Bitcoin blockchain. Okay. So, what we see here is that now Bob is publishing on the Bitcoin blockchain, okay, as we see here. Very important is that it uses the same hash lock that was used, which is this H. Okay. So, the same hash lock that was used by Alice, and one can see that hash lock value, this H. So, this H was used to lock the contract that was created by Alice, and now that contract that Bob creates, he is also going to lock it with the hash H, and it will have a time lock of 5 delta, which is little less than the timeout of Alice. And then what does this contract do? This contract transfers his bitcoins to Carol. Now, what would be the next step? As you can rightly guess, that once Carol sees that indeed Bob has created this contract in the Bitcoin network, so then first this is to be confirmed, and then Carol can publish a contract on the automobile title blockchain. As we said, that this is another blockchain which is not dealing with cryptocurrencies, but keeping track of asset, which is these vehicles titles or the registration information, and again with the same hash lock H. So, that is very important, and it has got a timeout which is even before Bob's timeout. Okay. So, now what has happened? These different contracts have been published. So, Alice would confirm that Carol's contract has been published on the title blockchain. So, Alice knows that if she transfers the money to Bob, and then Bob can transfer to Carol, and finally Carol will be transferring the title. But actually what we will see is that it works in the other direction. So, once Alice has seen that Carol has published her contract, that means Carol cannot go back on her promise to transfer the title, she would send S, that is the secret, to Carol's contract, and in the process the title would be acquired. Why? Because Carol's contract was also created using the hash of that same S. S was not known to Carol, but that hash was not known to Carol, which was used to lock the contract. So, because Alice knows what is this S, Alice can send S to the contract created by Carol, and in the process she would acquire the title, but it would also reveal that S to Carol. As soon as Carol sees that S, that means now Carol knows that Alice has revealed, means Alice has now got the title of her Cadillac. So, that means Carol's Cadillac is now in Alice's possession. So, first thing that Carol has to do is that she has to get the money from Bob's contract, which is in Bitcoin. So, what Carol would do is that she would send this S to Carol, sends S to Bob's contract and acquires the Bitcoins. But in the process, again, that would reveal that S to Bob, and by this time what has happened? Bob's money has gone to Carol, Carol's title has gone to Alice, but Bob yet has not got anything. So, Bob immediately, as he gets that S, so he would send it to Alice's contract, which will in the process let him acquire the altcoins, and in this way we complete the entire swap. So, this three-party swap will be completed by this method. So, if you see this particular diagram, it explains the same thing in a pictorial form. So, first we have this Alice creates that S and generates the hash, and the first bold line is this contract with hash lock of using that H and a timeout of 6 delta, and then we have the second one of the second contract created with the same hash lock, but with 5 delta, and finally the third one that is created with the same H, the hash, and timeout of 4 delta. And then in figure 2 we show that Alice has revealed S, and then the car title is transferred to her, but in the process Carol learns that S, then Carol reveals S and then gets the Bitcoin, and finally it is revealed to Bob in the process, and then Bob gets the number of altcoins from Alice's contract. So, this is a pictorial representation of what we explained. Now, you might wonder that what if something goes wrong in between, because there are now multiple parties involved, in contrast to the two-party case that we talked about in our previous lecture. So, if any party halts while contracts are being deployed, then all contracts eventually time out and trigger refund. So, what it means that at any point of time, as we discussed here, say Alice first created this contract, okay, and after that nobody proceeded, then what will happen? So, Bob has not created any contract, Carol has not created any contract, and hence after that 6 delta Alice will get back the money, that is her altcoins. If after this second step in the top row, after Bob created the contract, then what will happen is that say Carol is not proceeding. So, after some time Bob's contract will first time out, which is that 5 delta, and then Bob gets the refund, and after 6 delta Alice will get the refund. So, you see that in between, if it halts, then all contracts will eventually time out and trigger refunds. Now, that is when these contracts were getting created, that is in the upper diagram, and in the lower diagram we see that after these contracts have been created, now what happens if some of them halts. So, if any party halts during triggering of contracts, that means when the contracts are now getting executed, only that party would end up worse off. So, for example, even after say Alice revealed that key S and got Carol's car's title. So, Alice has got the Cadillac, but then suppose Carol is not doing anything even after it was revealed, then S, she knows S, but she is not proceeding with her claiming of the Bitcoins from Bob's contract. Then what would happen is that Alice gets the Cadillac, and because Bob does not yet know that S, so Bob cannot claim Alice's altcoins. So, Bob could be having a problem, but now you see that Bob's contract also has this timeout. So, that is why it is a hash time lock. So, after Bob's contract times out, Bob will get her refund. So finally what will happen, this misbehavior of Alice would only harm herself, both Alice and Bob will not be worse off. So that is what we started with, that if any party halts, any party does not behave or does not follow the particular protocol, then the conforming parties, they are not worse off. So you see that Bob gets a refund, so he did not gain anything. Alice also got back, after her time out of 6 delta, will get back her altcoins, and in the process she also got the Cadillac. So we see that only Carol lost out. Alice got her money refunded and also got the vehicle. Bob did not gain anything, but did not lose anything also. It was only Carol who lost. So that is the whole point, that by not following this particular protocol, you are going to only harm yourself, and even if they collude and try to do something, only those parties are likely to be worse off, and at least they are not going to harm the ones who are following the protocol. So that was the last slide about interoperability in permissionless blockchains. Now we will move on to discussion on interoperation in permission blockchains. So here the networks are designed to be private. We know, we have discussed about it, for a closed consortium, and different business sectors tend to have different groups of organizations and thus have separate blockchain networks. For example, there is a logistics blockchain network called TradeLens, so it is a permission blockchain. So there is another one, a trade finance blockchain network, say called WeTrade, and there are others including IBM Food Trust, Food Supply Chain, and so on. So we discussed about these supply chain blockchains in our first few lectures. So they typically continue to operate in isolation. So if there is one particular such blockchain like say TradeLens, which is a logistics network, it does not as such have any interaction with say the trade finance network or so on. So there is a need for interoperation between different such isolated networks to achieve certain common business goals. So it will facilitate the business processes if they can really interoperate. So here the challenge is that this interoperation is specifically about verifiable data transfer. So unlike permissionless blockchains, which were only based on typically asset transfer, as we said, either of cryptocurrency or other types of assets like vehicles title or maybe land say rights or land title or any type of other property title. So instead here what is important is that if we consider logistics, if we consider supply chain, if we consider say shipping, so there is nothing like an asset transfer, it is more of verifiable data transfer between separate permission blockchain networks. And data in a blockchain network of course is generated by transactions going through the consensus process, which we have discussed. So what is important is that the transfer of data should be consistent with the source network's state, because the data is moving from a source network to a destination network. So it must be consistent in the source network, and we are talking about multi-party trust, that when one network consumes state from another, the target network is consume the state from the source network, it needs to establish the validity of the state, which must be as per shared consensus view of parties in the network. So if say network B gets some data from network A, it is to be ensured that data in the network B is a consensus view of the parties in that network A, so that network B does not get some data which is not really, which has reached a consensus in the source network, which is network A. Let us take a look at this example. So as we mentioned that there is this WeTrade is a trade financing network and TradeLens is a trade logistics network. These are two business verticals, and then we talk about some simplified form, that is why we treat them as simplified WeTrade and simplified TradeLens, as is mentioned here. So this we shorten as SWT and STL, and on the left hand side you see that we have one blockchain here as is noted here, and then there is another blockchain on the right hand side with these dotted rectangular boundaries, and we see that the seller is the entity which is common in the two networks which are otherwise independent. And in the left network we have the buyer, the buyer's bank and the seller's bank, and on the right hand side in the STL we have the shipping companies. So what happens is like this buyer wants to buy something from a seller. So buyer raises a purchase order on the seller, and then the seller will have to transfer the goods. Say let the buyer is a company in India which is trying to buy say some raw material from a company say from another country like say Australia. So, a buyer is a company that makes say wool yarns, and this seller is a company in Australia that supplies wool. So, raw wool will come from the seller in Australia to India's this yarn manufacturer. So, what has to happen is that buyer will place an order on the seller of certain amount of say Australian dollars, and then what has to happen is that the seller must be convinced that if the seller indeed ships the goods to the buyer, gets the payment. So, that is guaranteed by buyer's bank by offering what is called proposing an LC or the letter of credit. Okay. So, the seller's bank, when it is convinced that indeed buyer's bank is providing the letter of credit, means the payment would be guaranteed if the goods are received in good condition. So, the seller's bank will tell seller that it is fine, so you can send the consignment. Now, it comes to the right hand side. So, there is this shipping company which is shown as the carrier. So, it will actually have to load everything in the containers and then it will be shipped so as to reach the buyer. So, that is the type of operation we are talking about. So, for that the seller will request a booking, the carrier will accept the booking, and then the seller will create the consignment, that is all those raw wool will be put in containers and loaded in the carrier. And now, say there must be say some way for this first blockchain to know that the goods have been loaded and the ships are ready to sell or they have already sailed. And once they sell, then maybe a part of the payment can be made to the seller and so on. So, that means this information from the carrier, that is the shipping company, has to reach say the seller's bank, or essentially in this particular blockchain which is this SWT blockchain. So, that is what is shown by this dashed green line, which shows that this information has to come back from the STL blockchain to the SWT blockchain. And which information? This is what we call as the bill of lading, means that the proof that the items have been loaded and they have been now sold, or the carrier is starting to sell from the source port, like some port in Australia for final destination in India. So, that is the type of example in a simplified sense we are trying to do. So, it means that we need this transfer of data, that is the bill of lading, from the STL blockchain to the SWT blockchain, and it is in that context we are talking about interoperability in permission blockchains. Each of these is individually a permission blockchain, typically say these are Hyperledger Fabric blockchains, and now we make them interoperate. What is important is that the data that is moving from this STL blockchain to the SWT blockchain, that is the bill of lading data, that should be the consensus view of the parties which are involved in that STL blockchain. So, there you see that the parties are the carrier and the seller. As you see, seller is common to the two blockchains as I mentioned. So, both of them must agree that indeed the items have been loaded and the ship is ready to sell or it has sold, and hence the bill of lading is, the data is a consensus view of those parties in the STL blockchain. We have these short forms and which have been explained here for your convenience, and also giving you some ideas what they mean, because all of you may not be really familiar with these terms of letter of credit and bill of lading. So, we have ensured that we give you some idea, and of course, this reference to this paper which talks about these in more detail. So, you can take a look at that, and also you can search on the internet for more details about these two different blockchains, WeTrade and this trade lengths, and also about these terms letter of credit and bill of lading and so on, which you can get more information about what they really mean and how they are used in such type of business. Now, for our use, what we are now really interested in is that how this verifiable data transfer will take place in such a permission blockchain. So, we have first explained what is the requirement. Now, we are explaining how it really can be done. So, each data block in a network has a set of endorsements or signatures for consensus. So, in the source network, which is say this network B, which is the seller, as we said, that from there we have the sellers and the carriers network, that is the trade lanes network as we said, which is network B, and network A is the destination network, which is this example that we talked about, the we trade network. So, this is the network A in this particular diagram. So, from the source, which is from this network B, the data is accompanied with a set of signatures attestations, which show that indeed it is a consensus view of the parties in that network, and then these attestations are validated in the destination network. That means that when it goes to network A, that is again, if you remember, it is the we trade network. So, there it should be validated that it is willing to accept that data, because now you see that for this network A, data is coming from somewhere else. So, it has to ensure that whatever is coming, it is willing to accept that data. Similarly, when it is being generated from network B, it is to be ensured that it is a consensus view of the data, and also as we will see in the next slide, that they should be willing to share this data. So, that is also very important. So, as we see here in this architecture, so we have exactly the same copy of the in the left hand side as well as in the right hand side, assuming that these are similar type of network, as we say that this could be say hyperledger fabric network type of network. So, what we have here is that we have the basic peer to peer network with the ledgers, we have the consensus protocols, but this being a permission blockchain, we need to have some membership manager also, which will denote that who can do what, the access rights and so on. There is this configuration management, the data acceptance policy, that means when they are going to accept a data from another network. Also they have to have this module called exposure control, which says that when we are going to share some data to another network, we have to be careful about how much our internal information will be exposed. So, this exposure control is an important block, and of course, there are these system contracts. So, exactly we are having the same copy mirror image of the left is on the right, and then assume this right is the source network, which we denoted in the previous one as network B, and from there the data will move to network A. Again, network B is like this simplified trade lanes, and network A is the simplified we trade. Now, how is it going to happen? So, we have this notion of these relays, which are going to handle this communication between these two permission blockchains for interoperability. So, first of all, what happens is that from the left, the final destination, which is as shown here as network A, will make a request to network B. So, that goes through the relay, through this communication channel to the relay on the right hand side, and there what it will have to do is that from here it has to ensure that it gets the data based on the consensus protocol, also based on this exposure control, which is shown in step 6. So, it will have to ensure that if the data that has been requested, if this network B is going to share that data to network A, then it is not going to be at risk. So, if that is all fine, then what will happen is that then the data will be sent through this relay, point number 7, and back to the relay in the destination network, which is through this step 8, and there what they have to do is that they have to follow this data acceptance policy, and then they have to ensure that it is safe to accept the data, and this is really having sufficient number of attestations. So, that is what we say here is that data acceptance is validate the data that is received from a foreign network against the policy that defines say how many signatures are required and other conditions to verify the data. So, of course, that relay service is what is important, it provides a means of communication between the two separate networks. So, that is what is important. So, one has to of course have these relays to be in place, which will help in the interoperation between these two different, but they are permission blockchain networks. Once again, I would like to mention that this is an example, a particular research work that was published as in this paper, that is in this 20th International Middleware Conference in the industrial track in 2019. Of course, one can think of other methods. There are also some other research work that have been published. So, one can go through those. This is one to motivate you as to how actually such interoperability can be done in permission blockchain networks. So, the steps, as we said, that proof request is generated consisting of a verification policy which has to be met by the source network. So, that is step 1. Then access control policies are to be checked. response data along with proofs are sent back through the relay, and proofs are validated against the verification policy. So, that is what we need to follow, so that the data can move from the source network, that is network B, to the destination network, that is network A. And here is a detailed diagram similar to an UML sequence diagram. You can say that we have from in the timeline is in the y direction growing in the vertically down, and then we have this generation of key pair getting the certificate. So, you see that all these are happening in that SWT network. So, it is using SWT chain code, SWT seller client, what it is doing, and then finally it goes to SWT relay. So, you see that from the top the information is first flowing from the requirements in the SWT network to its relay, which in turn is sending this request for bill of lading, as we said, to the STL relay, which is on the other side. Because if you remember, just for your understanding, that here we said that this bill of lading information is to move from the STL network to the SWT network. So, SWT network has originated the request as shown in this sequence diagram, that the corresponding chain code has generated this request, which is now asking for this bill of lading from STL with appropriate arguments and the certificates that are required, which are now transmitted by SWT relay to the STL relay, and then it is going to STL's chain code, and then it will validate the access control rules that are there and look up for the SWT configuration. That means whether SWT is indeed a valid destination where I can send my data. That is what STL has to ensure, that there is no additional exposure that they are going to face, there is no additional risk. So, now they will encrypt the result, which will be sent along with the endorsement to the STL relay. STL relay will now transfer it to the SWT relay on the other side, that is the encrypted result with proof, which will now be decrypted, and then it will be checked for the policies, whether it is okay to accept the attestations that have been made by the source network, and then once that is done, then of course that will execute the appropriate transaction. So, nothing will happen manually. So, all this will be happening through chain code, which is now has accepted the bill of lading that has come from the other network, and based on that now it can trigger further actions as to what the bank has to do. The buyer's bank may have to send some part of the money as advance to the seller's bank, and all those things all will happen in an automated manner, because this particular smart contract will now be executed. But it is executing only because it has got the data which is coming from a different network. So, that is a very interesting work on such permissioned blockchain interoperability, where we showed how data can move from one network to another, but at the same time it should also ensure that autonomy is not violated. So, that is the important part. So, with that we come to the end of our discussion of interoperability in blockchain networks. So, to conclude today's lecture, we have explained how HTLC is used for three-party swap. That was our initial discussion, the initial topic, which was an extension of the two-party swap that we explained in the previous lecture. Then we talked about permission blockchain interoperability. Specifically, we talked about data transfer across different Hyperledger Fabric networks. And references, as we keep mentioning, that the papers that we have referred to, the two papers, the middleware conference paper for the permission blockchain and the PODC paper for the permissionless blockchain, and there are a lot of other resources as I already mentioned. So, you are always encouraged and highly recommended that you go through those resources that will enrich your knowledge in this topic. But with that we come to the end of our discussion of interoperability in blockchain networks. So, we will next move on to another topic from the next lecture. Thank you very much for your attention.